Okay. So on the data platform team, we recently made a few improvements to our CI. And the idea with this workshop is to share with you what we've done and to maybe start a discussion about if this tooling would be useful for your teams. And if so, if there's any abstractions or changes that need to be made to the tooling to make that happen. Let me share my screen. Can you see my screen? Okay.
Yep.
So these are the 4 topics I'd like to cover today. We'll pause after each if you have any questions. If you have any questions during, feel free to unmute and interrupt me. I only have a single screen, so I can't see if you have a question, so just feel free to unmute and interrupt. And my goal is to leave a lot of time for questions because the focus of this workshop is how can this information be useful for you. So let's start with caching, Charmcraft pack, and integration tests. So you can see here, this is an example of a workflow run before we added caching. And this is an example after we added caching, and it went from around 40 minutes to 20 minutes. Before we jump into how the caching works, I want to cover GitHub CI matrices. So you can see here, this is the MySQL charm. The way that our tests are set up is that we have a separate talks environment for every Python test file. And then we have a separate GitHub job for each of those talks environments. And you can see that most of the job is the same. The only difference is the name of the talks environment. And so we moved this into a GitHub matrix. So we just moved the talks environment into this matrix. And then here we can access the value in the matrix. And you can see that we were already using this to test on Focal and Jammy. And so what this does when you have 2 keys in the matrix is that it will run all possible combinations. So this single job will create a series of jobs on multiple different GitHub runners, so different machines. And it'll create one for integration HA on Focal, integration HA on Jammy, integration DB router on Focal, and so on. Any questions about the matrix? Okay, so there's 2 things that we're doing with the caching. The first is that before our integration test included the build step, and now we have a separate build step and a separate integration test. So this means that when we're running multiple integration tests, we only have to build the charm once. And then the second thing we're doing is we're caching the LXC container used by Charmcraft pack. So by default, Charmcraft pack uses an LXC container to build your charm. On your local machine, after you pack the charm once, any subsequent packs will reuse that container, so they're much quicker. But on GitHub, it will create a new container from scratch for each CI run. And so the idea is that we're trying to cache the LXC container on GitHub like it happens on your local machine. And so here is what our integration test looks like. So you can see here we have that separate build step now. It's using a reusable GitHub workflow, which we'll come back to. And then here, the next step is in our integration test, we need to get it to, instead of building the charm, to use the packed.charm file. So there's 2 steps. First, we download the charm from a GitHub artifact. And so if you see here on the summary page of any GitHub action, you can view the artifacts. So here is where the charms that we built go to. And artifacts are used to share files between jobs and also to output files after all the jobs finish. So for example, if you have logs or like crash dumps that you want to view. So here we're downloading from that artifact. And then the second step is that we need to tell the tests where to grab the charms from. So we pass in this environment variable that comes from the reusable workflow. And then in the tests, in our talks file, we pass in that environment variable. We also pass in the CI variable, which GitHub Actions sets to true when it's running. And then here is where the way that our integration tests are written is that we are calling build charm from PyTest operator's ops test. And so instead of rewriting our integration test, we just overrode the build charm method in ops test to, instead of building the charm, just return the path to the charm file. And so that's exactly what this file does. It's a comptest.py file. So PyTest, when it runs any tests in the integration folder, will automatically use this fixture whenever ops test is referenced. So what it does is it checks if we're running in GitHub Actions, and if so, it will load that environment variable to find which terms have been packed. And then it overrides the build charm method to, instead of building a charm, just return the charm path. Any questions? Okay, so this is an example of what a workflow looks like without the caching. You can see it takes around 40 minutes to an hour. Here's what it looks like with caching. So this is the first time that it was cached. And you can see that it takes a similar amount of time. It takes 20 minutes to build the MySQL charm. And then here's an example after the cache has been built. And you can see the build is much faster. It only takes 2 minutes. If you ever are curious about how to manage the caches on a GitHub repository, you can go to the Actions tab and then Caches. It will show you all the caches. And you can see that we have we have 3 separate caches, and that's because the MySQL operator has 3 charms in it. The MySQL Kate's charm itself, and then 2 test charms. So it creates a separate cache for each of the charms. So this is the reusable workflow that we're calling to build the charms. And so this lives in a data pot from workflows repository that we share between all our charm repositories. And so essentially what it does is the first step is it finds what charms we need to build. And the way it does that is it looks in the repository and finds any charmcraft.yaml files. And then it will create a what this script is doing is it's creating a list of charms to build or listed jobs. And so for each version of a charm, so if a charm is built on Ubuntu 20 and Ubuntu 22, it will create 2 separate jobs. And then it passes that to the GitHub output. And here we're collecting that GitHub output. And so what it is it's a JSON encoded string of the charms that we need to build. And so here in the build step, we're creating a matrix just like we did before in the integration test, but this time it's dynamically created from a JSON string. So this will, if we have the MySQL Kate's charm on Ubuntu 20 and Ubuntu 22, it will create 2 separate jobs for each of those builds. Any questions? Okay. And so there's a few things I want to talk about. So the first is the cache key. And so here is where we're defining GitHub's cache key. And the way that, so for every cache on GitHub, it has a unique key. And that key is what determines whether, when you're running a workflow, you create a new cache or you use an existing cache. So if the elements of the cache key change and it doesn't match an existing cache key, it will create a new cache. So for us, we're looking at which charm we're building, which version. So each of those have a separate cache. And then if the version of Charmcraft ever changes, we're looking at the major and minor versions of Charmcraft. We update the cache to be safe. And then if the charmcraft.yaml, actions.yaml, or requirements.txt file changes, then we create a new cache because Charmcraft can't use the existing cache. So I'm going to skip how we import the LXC container and jump to exporting it. So we create a GitHub Charmcraft cache directory. And so when Charmcraft creates a container for your charm, it includes this number, and this number is the Unix inode. From my understanding, it's a unique identifier for a file. And so this is the Unix inode of the charm directory. And when we move the cache between machines, the inode changes. So we have to replace this inode with the inode on the new machine. And so what we're doing here is we're grabbing the inode of the charm repository, and we're just replacing inode with this text inode in all caps here. And then we're just exporting that to the GitHub Charmcraft cache folder. And then here is where we're saving the cache. And you can see we're just saving all the files in the GitHub Charmcraft cache folder. And so going back to the import step, sorry, I skipped a step up here. This is just a shortened version of the Charm Kubernetes action operator to just set up the environment, install dependencies. And so here's where we're importing the cache container. So here we're creating an LXC project for Charmcraft because Charmcraft hasn't had a chance to create it yet, but this is just copied from what Charmcraft does the first time you set up an LXC container for Charmcraft. Here we're grabbing the new inode, and then for each LXC container, we're replacing that placeholder text with the new inode. And then here, we're doing a little bit of a workaround. So Charmcraft, when you're on your local machine, when you pack the charm, it records what time you packed it. And then the next time you pack a charm, it looks at all the files in your directory. And if any of them have been updated since the last time you packed, it will include it in the new pack. But for us, this is a problem because imagine you create a commit on a PR branch, and then later on the main branch, you create a cache. And that cache is created after the changes you made on the first branch, but the cache doesn't have those changes because they're on a separate branch. And so to work around this, we're just telling Charmcraft that the last time it packed the cache, or the last time it used the container, was January 1st, 1970, so that it will update all files in your repository. And then, so there's GitHub has a limit on the cache size. So you can only have 10 gigabytes or gigabytes per repository. And you can see that these caches are fairly large. They're about half a gigabyte to a gigabyte. And the way that GitHub caches work is that when you're restoring a cache, if you're on a PR branch, you can only restore from that branch or from the main branch. So if you open PRA and then you open PRB, PRB cannot restore a cache from PRA. And so what this means is that we always want to have a cache available on the main branch, because otherwise new PRs will have to create a cache from scratch. And so when you exceed the 10 gigabyte limit, GitHub will automatically delete the oldest cache. And so our workaround is just to delete and resave the cache on main once per day. One thing to note is that we're not creating a new cache once per day. We're restoring the cache while the workflow is running, deleting the cache, and then saving a new cache just to get an updated timestamp. And the way we're doing this is we're just using the GitHub CI to make an API call to GitHub. So when you use the GitHub CLI in a workflow, it automatically replaces some of this information for you. And then finally, here we're saving the cache if there wasn't a cache yet, or if we're doing the deletion thing, which we run this workflow on a schedule once per day. And so this checks if it's on that schedule, and then that's how it knows how to delete the cache. Okay, any questions about caching?
Yeah. I was wondering, is the save action compressing the artifact before it gets saved to GitHub?
Yeah. So we're let me go back to it. So here we're telling LXC not to compress it. because GitHub has a more efficient compression, and yeah, it will automatically compress it. And so I believe the cache size is the compressed size.
All right, thanks.
Any other questions? Okay, the second topic is parallel integration tests. And so you can see here, this is an example of a test that we haven't parallelized, and this is an example running in parallel. And you can see that the total execution time is longer, but the amount of time you have to wait is shorter. And so the way we approach this is we first took a look at one of our integration tests, and we took a detailed look at the timestamps to see what in the integration test took the longest amount of time. And what we found is that the amount of the things that take the most time in the integration tests are building the term, which we just cached earlier, waiting for a term to deploy and reach its initial active status, or waiting for a term to scale up or down. So for the test function that we looked at, the test duration was 13 minutes and 48 seconds. And of that, 11 minutes and 41 seconds was deploying, scaling up, or scaling down. And so the idea is that on our repository, the way it's currently set up is that each Python test file runs in parallel. And what we're doing here is we're running parts of those files in parallel. So running 3 separate groups of a file or 3 separate parts of a file in parallel instead of just one file in parallel. And so to do this, essentially, if there's all our tests have a slow setup. So this is an example of one of our integration tests. All of them have a slow setup of deploying 3 units of MySQL. But from there, some tests have, after the setup, some tests are fast, and some tests are slow. And so if we have 2 or more slow tests after the setup, the idea is to put them in 2 separate groups so that we can run them in parallel. So you can see here, this is our setup. This test doesn't do anything slow afterwards, so we leave it in the same group. And then this group kills a unit and then waits for it to come back. So this test is slow, but it's the first slow test, so we can leave it in the first group. And then this test scales up and down the application. So we move it into a separate group. And the way we're grouping these is just using a PyTest marker. And then finally, this is another slow test, and so we put it in a separate group. So the 3 slow tests are running in 3 different groups. And so in order to make this happen on the CI, so our goal is to run these 3 separate groups on 3 separate GitHub runners. So in our workflow, before we run the integration tests, we need to collect what groups there are to tell the workflow how many runners to provision. So here we're calling PyTest with this collects group option. And so in our PyTest configuration, we're adding this collect group option. And if it's enabled, we turn on PyTest collect only mode. So we're just getting the names of the test. We're not running the tests. And then here, we're hooking into PyTest's hooks. So this is like a PyTest plugin, essentially. And so there's this PyTest collect modify items hook, which essentially is when PyTest is done collecting all the tests, you can modify what it collected. So if we see that collect groups option being called, we run this collects group function, which essentially looks for all the test groups across all the different files. And the end result is that it creates a list of groups by file. So for example, if we have a test replication file with 3 groups, the list will have test replication group 1, test replication group 2, et cetera, and then maybe test HA group 1. So it's each group per file. And then this is saved to the GitHub output environment variable. And then In our workflow, instead of running each of the files as a separate runner, we're collecting that JSON string just like before to dynamically create our group matrix. And then in the integration test, we're specifying the group file and the group number. And then back in our PyTest configuration, if a group number is passed, so here, when we're not in collect-only mode, if a group number is passed, it will filter the tests to only include those with the correct group number. And then one thing that we do is if it's missing a group number, instead of removing the test from the collection, we mark it as skipped, so it shows up in the CI output. And that's pretty much it. There are simpler ways to achieve this parallelization. You could just put the tests in different files. And we're looking into ways to make the group marking and the logic that handles that simpler or more reusable by moving it into like a PyTest plugin, potentially PyTest operator, potentially another plugin. And then this is what the CI runs look like. So this is the test replication file before parallelization. You can see it takes 30 minutes. And then here, this is group 1 of the file, 17 minutes. This is group 2. You can see it's its separate GitHub runner, 15 minutes. And group 3 is 13 minutes. Any questions about the parallelization?
Yes, you mentioned they share the setup, but now they're running on different runners. So the setup is running on all those runners still, right?
Yes.
Okay.
So you'll have a slower overall machine time used. Yeah.
Okay.
Yeah, like you'd have a couple extra minutes of some runner doing a little bit more setup, but your clock time is faster because you're doing several of them in parallel.
But it is a concern if you have limited GitHub runners, or if you're concerned about machine usage. It is less efficient in that sense.
Yeah. Or if your setup time was really long, and so you're only saving like 5 minutes and spending a whole bunch of minutes. But in your case, it's not. It was quite short now.
Yeah, that's the idea where we only, if there's more than 2 slow tests in a file, then we split them into different groups. But if there's only one and the rest of the tests are fast, it doesn't make sense to have the fast tests and the slow test in different groups.
Makes sense.
Any other questions? Okay, next I just want to go through some quick rapid fire CI tips that I've learned while doing this. So the first is that you can run CI tests on a schedule. And so this was really helpful for us to identify flaky tests because we could see over time if a test fails consistently on the schedule. And also if there's any like changes that happen to your workflow that aren't tracked in your repository. So dependency changes to GitHub runners, and it helped us identify when CI failure was not because of a PR that we created, but it was just because the underlying environment changed. So it's helpful to be able to look at the nightly CI run and see, oh, CI is failing because of some change. I don't have to spend time trying to figure out why my change caused a CI failure because it was something external to the repository. Another thing that we added to our repositories was a mark for flaky tests. So it's just a PyTest mark. And what this allowed us to do is we had some tests on the MySQL charms that were very unstable, and they were blocking PRs, but we still wanted to stabilize the tests. And so what the flaky mark let us do is that on PRs, we skipped the flaky tests so it wouldn't block us from developing and merging PRs. But then on the nightly runs, we ran the flaky tests to sort of identify how often they're flaky and to get logs about what's causing them to fail. And so this helped us to stabilize those flaky tests. And then also, we recently renamed the flaky mark to unstable because when we're creating new tests, we automatically add the unstable mark. And then we check the nightly runs for a few days to see if it's stable, so that new tests that are added don't block PRs. Another thing that John showed us was GitHub concurrency groups. And so when you're creating a PR, you'll often push a lot of commits to it. And so say like you push a PR and your CI takes an hour to run. And then while that CI is running, you make changes to it and you push another commit. By default, GitHub will keep all the old runs running. And so if you like push, say, 5 commits to a branch, you could have 5 tests running at once when all you care about is the latest test. And so what this concurrency group does is it says for our branch, only run CI on the latest commit. So if you push a new commit, it will cancel any in-progress jobs on that branch. And the way it works is that you need to have a unique name for each concurrency group. And so it's just by the workflow and the branch. And so if these are the same and you push a new commit, the latest commit will cancel any old jobs. And then another thing we learned about is that for each job, you can add a timeout. So by default, GitHub has a 6-hour timeout for jobs. And sometimes CI fails and it stalls out and it takes that full 6 hours. And we were recently running into issues where all of the runners on the Canonical GitHub organization were full. There's a 60 concurrent runner limit. And some of that was caused by workflow runs stalling and taking 6 hours. And so if you add this to your jobs, this can help. If there's a workflow failure, if something stalls out, it won't clog up the runners that everyone else is using. So we've added this to all our jobs, a reasonable amount with buffer, just so that there's not a 6-hour timeout. And then the last tip I want to show is Foresight. So Foresight is a GitHub CI observability tool. It basically gives you a dashboard of all your CI runs. And so GitHub's UI is not very easy to navigate, to track workflow failures across repositories or across a long period of time. And so Foresight gives you a much better dashboard for that. You can see like it gives, it can tell you your workflow runs that take the longest amount of time. It can show you how workflow run times change over time. You can even go into view an individual process trace of everything that happened on the runner, and you can look at things like CPU usage over time and memory usage over time to see if there's the bottleneck, and maybe a larger runner would help. This is something that we recently added on the data platform repositories, and we're working with IS right now to try to make this so that the data is publicly available without an account. And I'm sure in a few days or in a week or two, they'd be able to help you add this to your repositories if you're interested. I think it's free for all public repositories. And it's the investigation I mentioned where we looked at the timings of tests to figure out how to parallelize them. This tool would make it much easier to do that for your tests. You can see it even has, if you integrate it with your workflow, it will give you information about individual tests and how long they take to run and how flaky they are. Any questions about any of those tips? Okay, the last thing I want to talk about is the sort of development environment we set up for reusable workflows. And so I showed a little bit of this, but we created this repository for the reusable workflows. And the idea with this is that these are, so there's GitHub Actions, which are written in JavaScript or TypeScript. And then there's reusable workflows, which are written in YAML. And so this is the reusable workflows. And the idea with this is that we're using YAML and Python scripts so that it's a little bit easier to maintain for Charm developers than something like a TypeScript or a JavaScript action. And so recently, on our Charm repositories, we were using the charming actions upload charm action to release our charms to Charmhub. But we ran into an issue where that only supported releasing a charm that's on one Ubuntu version, and we needed to release on multiple Ubuntu versions. So we rewrote the upload charm action as a reusable workflow with YAML and Python, with the idea that it would be easier to maintain and to make changes and to extend it in the future. So this is just an example of one of the reusable workflows in this repository. You can see it's pretty similar to the upload charm action, where you select the channel. And it's a little bit different in that it has a separate build job. So this is building without any cache. And then the release job just selects the channel, and then you give it the name of the artifact, the GitHub artifact that has the built charms, and it will release it to Charmhub. And so this build job is interchangeable with the one with the cache. So you can use the same build that you use for your integration tests to also release the charm.
Maybe a quick comment on that. In the telco team, we had at some point in the last year, we had an issue where we ran the integration test on a charm. It worked fine, and then we pushed the charm to Charmhub, and that charm was completely broken and couldn't deploy. And it turned out that the build step, since the action is using destructive mode, it built the charm differently than what we had tested. So one thing we started doing was to take the charm that was built by the integration test and cache that, and then publish exactly that charm to Charmhub to make sure that what we published was actually what we tested. So maybe that could be an improvement there.
Yeah, and the way this is set up, I think you'd be able to do that. Sorry, go ahead.
Oh, sorry. Yeah, I was going to say there's a question on the chat.
Yeah. So I'm not sure if it only works with AMD 64 charms. I don't know of any reason it wouldn't work with other charms, but we've only tested on AMD 64.
Okay, because as far as I know, what's provided by GitHub Action are AMD 64 VMs, so that's why I was asking.
Oh, yeah, I think it does use like the LXC container instead of destructive mode, so I'm not sure if that changes things. And I think it's possible to have like self-hosted GitHub runners on different architectures. But I don't think there's anything with the reusable workflow itself that if you had a runner that could build a non-AMD 64 charm, that would, I don't think there's anything that prevent you from doing that.
Okay, just for our own usage, we have a job set up on Launchpad so that it syncs from GitHub and then build on all the architectures that Launchpad is able to build on, and then we publish from there. So if other folks are looking for a multi-arch, that might be a way.
One thing I was going to add, Carl, the reusable workflows are super helpful. A gotcha with them is there's a recursion limit.
Yeah.
That is, I think they extended it to 4 or 5 now. It used to be 3, but yeah, so like you can't nest them infinitely, which probably doesn't matter. But if you really want to go at them, it could matter. And also there's also composite actions, which are confusingly similar to reusable workflows, but they feel a little bit more like writing an action instead of writing a reusable workflow. And they can also be pretty helpful. I've found in the past they feel a little bit easier to write tests for. It's like in the reusable workflow that you've got here, there's like some Python, like some run blocks with some Python in it or whatever, right? And in the composite actions, it's a little bit easier to make those into like scripts with tests and then be a bit easier to consume and that sort of thing. But just there's different reasons why they're better and worse.
They actually are scripts. We'll get into that in a second. But yeah, it's definitely harder to test some of the workflows. I think there are a couple limitations with the composite actions around secrets, or there's something, I remember seeing something about.
Yeah, there's like subtle differences between them where like certain situations, one might be better or worse than the other, but the details are, the sort of thing you look up every time you try and use them.
Yeah. And like one thing with the reusable workflows is that you can only use them at the job level. So you can only call them as a job versus actions you can call as a step. So if you want to integrate it with other steps, I think a composite action is able to do that, and reusable workflows are not. So going back to the action or to the workflow. So like the core idea with this repository is that these are workflows that Charm developers are able to maintain, since it's mostly Python, a little bit of some YAML configuration, and a little bit of Bash. And so this is the reusable workflow that we're using for the release Charm. And so it's fairly straightforward. There's this Git workflow version, which we'll come back to later. And then the workflow itself, here is just doing some setup, installing dependencies. And then here we're calling a Python script. And so that's the script here. And essentially what this does is it looks at all your Charm files in the artifact, uploads them to Charmhub, stores the revision, and then if you have any OCI images, it will pull them from Docker and then upload them to Charmhub and store the revision. And then for each Charm file, it will release it to Charmhub with the correct revisions. And so one thing that we ran into with upload Charm action was that it tries to upload the resource before it uploads the Charm. And so if you add a new resource to the Charm, you have to first upload that Charm with the metadata.yaml that contains the resource to Charmhub. And so that action doesn't work. You have to manually do that before you can start using the action. And so with this, when we created this action or this workflow, we were able to fix that by first uploading the Charm and then uploading the resources. And then it stores some info for the GitHub release. So it just tells like what revisions it released and what OCI images were included, and saves that to the GitHub output. And then all we're doing after that is using the we're tagging the repository with the revision number, and then using the GitHub CI to create a release. And so this is a fairly, the hope with this is that it's fairly easy to maintain. So this stuff we'll come back to in a second, but all it's doing is downloading the Charm files from our artifact, and then calling a Python script, and then calling the GitHub CLI with a little bit of Bash. And these two files contain the entire workflow. So the hope is that for any Charm developer, if you're using a reusable workflow or an action, that if there's a new feature that you need to add, or if there's a bug fix, or if you need to extend something in some way, that it's easy to dive into the Python and into the YAML to be able to do so. There's a couple things that we had to do to get this to work. As Andrew mentioned, there's a few limitations with reusable workflows. One of the major confusing things about reusable workflows is that when you call a workflow, it has the context of the workflow that called it. So if in the workflow you say, what is the current branch, it will tell you the branch of the calling workflow. And so it's really hard by default to figure out what version of this reusable workflow is running. So on this repository, we version the reusable workflows, but GitHub doesn't provide an easy way to figure out what version of this workflow running. And we need to figure out that version to be able to get the Python script from the repository and run that Python script, because it's not in line with the workflow. You can see that it's possible to inline a Python script, but it makes it harder to test and lint that Python and to share that Python between workflows. And so we wrote this action, which when you can see in the reusable workflow, we're calling this Git workflow version. And what this will do is if you call the workflow with this @v2 tag, or if you call it at the main branch, this Git workflow version will figure out what version the reusable workflow is called with. And so just briefly how that works. It checks out. So we can get the name of the workflow, the caller workflow. So it will look something like this. It will give us the repository and then the path to the file and then the version on the caller repository. And what this does is where you check out the .github workflows folder from the repository, and then we search through all the YAML files and we search through the YAML file and we look through all the jobs to see if any reusable workflows are called. If the workflow we're looking for is called, we just add that to the list of versions. If another reusable workflow is called, we recursively call this function again on that workflow file to see if there's a calling workflow that calls a reusable workflow that calls this workflow. And essentially, it just will find all the versions of the workflow file we're looking for, check that there's only one version, because you can't have, if you have separate files calling multiple versions, it can't resolve that. And then it will save that version output. And so in our workflow, we can just call this reusable workflow to figure out what version is running. And then a couple other things that we did in this repository. We set up an automatic semantic versioning release. So essentially for each PR, you prefix it with patch, compatible, or breaking, and it will automatically update the semantic versioning. And then also there's, it maintains release tags. And so we have this major version tag. So you can pin the reusable workflow to a major version, and the automatic release workflow will automatically update that major version tag to match the latest version for that major version. So that's some tooling that we created around to share reusable workflows. And this is tooling that you could definitely reuse if you're looking to share workflows across your team. And again, the whole idea with this is that because it's in Python and YAML, that it's easy for Charm developers to dive into it, to extend, to fix, and maintain. Any questions? So that's all I wanted to cover. If anyone has any questions or is curious about how you could use this workflow in your own repositories, or if you have any questions about that, feel free to ask.
Thank you. This was great. Lots of great ideas that I will definitely be looking into in my team and sharing with my team.
Thank you, Carl. This was amazing. I mean, this was truly like next level shit. Like I wrote, this is really amazing. I'm actually glad you recorded it. But perhaps we can. Should we end the recording now, or do we
Sure.
continue with the maybe so people would be more comfortable